In this video, we're going to graph a quadratic function from intercept form. Now, this is also one of the easier ways to graph a quadratic function, and intercept form, if you remember from your notes in the last video, it was a times x minus p times x minus q, where the x-intercepts, I'm just going to write x-ints, are at p comma 0 and at q comma 0. Guys, the x-intercepts are simply where the graph hits the x-axis. It's as simple as that. So we can quickly and easily find two coordinates where this parabola will hit the x-axis. When I look at the equation that's given to me, if I see an x plus 2, that tells me my p-value is really negative 2. Think about it. If we go back to the original form here, which is this guy, x minus p, maybe I highlighted that a little too much there, which is just x minus p. P is the number I'm subtracting from x. So if I see an x plus 2, I know I'm really subtracting a negative 2, which is the same as adding. Or if you prefer, you can think of it just taking the opposite of what you see in the parentheses. So I know I'm going to hit the x-axis at negative 2. That's the coordinate negative 2 comma 0. My q value is going to come from that binomial. What I'm subtracting from x there is just a positive 4. So I know my second intercept is going to be at 4 comma 0. So just by looking at the equation, I can plot negative 2, 0 right there, and 4, 0, which is 1, 2, 3, 4 right there. Now, what's going to be the next step is to find my axis of symmetry. My axis of symmetry is the halfway point in between those two intercepts. Now we could probably figure that out just by looking. It seems like the halfway point is right here at 1, and I think that is the case because I can go 3 units to the right and 3 units to the left, right? 3 units that way, and I can go 3 units that way, and this is definitely the halfway point. So in this particular problem, getting the axis of symmetry isn't really that tough. That would be it. Sometimes it's not quite as obvious. The axis of symmetry is really the average of the x-intercepts. Okay, so an easy formula you can use if you want to average the intercepts, just if you want to know the average of any numbers, you would add them together and divide by 2. So if my intercepts are p and q, I would have to add those values together and divide them by 2. This gives me the average of the values. Just to show you that it would work, let's say we didn't know that the axis of symmetry is where it is. I can plug in the p-value of negative 2 and add the q value of 4 and divide by 2. And that would give me 2 over 2, which is 1. X equals 1 is that particular line. X equals 1. Now, this is really good news. You might think, okay, well, big deal, we have the axis of symmetry. But if you remember, one of the beautiful features of the axis of symmetry is that our important vertex lies somewhere on there. It has to. The axis of symmetry always passes through your vertex. So I know right now that my x coordinate of the vertex is a 1. I do not know what that y coordinate is, however. So to figure that out, I can plug in x equals 1 into my original function, which was y equals negative, and then instead of x plus 2, I can write 1 plus 2, and instead of x minus 4, I can write 1 minus 4, and simplify. That's going to be minus 1 plus 2 is 3, 1 minus 4, negative 3, and if I multiply all that good stuff, I think I'm going to get a y equals 9. Now I know my y coordinate. Let me erase this question mark. I now can plug in there, hey, I know it's at 1, 9. Hopefully I didn't write all over this thing. Let's see if I can plot that coordinate. Let's go up 1, 2, 3, 4, 5, 6, 7, 8, 9. That looks like it's right here. I'm kind of using a bigger marker for that point because I feel like it's hard to sometimes plot it with this stylus. So I have my vertex, I have my two intercepts. I can make a smooth U-shaped curve that goes through this. So clearly this parabola is opening downwards. I'm going to go through my vertex. Sorry about that, I kind of went a little bit too high, but I think you get the idea. And it would look like this. Notice, once again, kind of an easy thing to double check. My graph is opening down. I hope I have an a value that's negative. And you know what? Right in front there is that negative sign. My a value is really a -1, which tells me it does open down. So that's just a quick thing to check to make sure that I'm on the right track with this graph. Looks good to me. Let's go to one more example. And here, let's see if we can do this rather quickly. I'm going to right away just write down what my p-value is. If I know I have a x minus 3, my p-value is really positive 3. My q value is going to come from that guy. If I have x minus 1, I know my q value is positive 1. So I'm just going to plot the point at 3 and at 1. Now, what's halfway in between 1 and 3? Well, a 2. So I know my axis of symmetry goes right there. It's nice and beautiful looking. Let's go ahead and use that x value, which on the axis of symmetry, my x-coordinate is 2. That's the equation of the axis of symmetry, x equals 2. So for my vertex, I know I have a 2 for my x-coordinate, but right now I am lost. I have no idea where my y-coordinate is going to be. If I plug in a 2 for x, though, into my original function, I'm going to get y equals 2 minus 3, and then 2 minus 1. So that's going to be -1 times 1, which will give me a -1. So I now know that my y-coordinate is a -1. So 2, -1, right there. And if I draw a smooth U-shaped curve through there, it's going to go something like this. Opens up. What's my a value? My a value, there's no number there. It's not 0, it's 1. That's positive. And it's opening up. I feel pretty good about that. Hopefully you feel like graphing from intercept form will be easy when we practice some problems. Thanks for watching.